So thanks for everyone for coming. Just to gauge the audience, if you could show me or put your hands up if you are new or relatively new to MuleSoft or the Anypoint platform. Wow, that's a large number of you. That's great. Who here is either a Salesforce admin or a Salesforce developer? Perfect. Yeah, about half the room. Okay, so just as I thought. So I have a few slides where I'll take a step back and kind of show what MuleSoft, the problem it was meant to build, before I get too technical. So don't worry about your inexperience. I'll get you through it. So this is the legal slide I was told to put in. I have no idea what it means, but from what it read, it's something about looking forward. All Salesforce implementations usually will involve the same process. Step one is to set up Salesforce. This usually involves setting up a sandbox, maybe on a custom instance, implementing a data model, creating some user accounts, and then handing it over with some training. And then as you're walking out the door, they no doubt will stop you and say, oh, by the way, we also need help with you to integrate with our existing systems. This could be an e-commerce site such as Shopify where they're taking orders, some forms on a web page where customers are entering data into, or possibly an in-house built legacy CRM system that they want to migrate to Salesforce, but chances are it's going to be a while. If you decide to turn around and stay to help with the integration, you'll need to first find out what your options. So Salesforce provides two applications that you can use. One is called the Salesforce Import Wizard, and the second is the Salesforce Data Loader. The Import Wizard is a manual process. It's inside the Lightning platform. It's CSV-based, meaning that you import a CSV file from your local machine. It can only process 50,000 records, and you can only map to 5 of the standard objects in Salesforce. The Salesforce Data Loader is a manual process again, but this time it's an application that you install on your machine. It's CSV-based file again, but this time you can map to all the standard objects in Salesforce. And there's a slight mapping feature where you can have some extra fields in your CSV file that are basically ignored. So if you decide to turn around and, the good thing, however, the biggest hurdle in using both these applications is getting your CSV file with all the organization's data already formatted into the Salesforce object model. If you're familiar with it, you'll know that Salesforce has a pretty strict model that you need to follow. Accounts are mandatory. They link to contacts. Orders have order items. Product lists are managed in price lists. The good thing is that most systems, including Magento, will allow you to export their data into CSV file format. So this icon in the middle is supposed to represent the chaos of the process of transforming the source CSV file into the Salesforce CSV format. This usually involves merging and splitting text, deleting some columns, creating new temporary ones, cleaning up some data, and for sure, formatting some dates, currencies, and numbers. So you think, great, that's not a big deal. We have Sally or Rick, who's an Excel guru. Or if you're not that lucky, you did some formulas in Excel back in school, didn't you? You can give it a shot. The problem is I've seen far too often as this manual process becomes a normal monthly, daily, or even hourly business task. This is a complete waste of a person's expertise, potential, and basically life. And this is where I want to help. Many studies contend that roughly 50% of a workday is filled with busy work, activities that keep a person busy but have little value in itself. The example I use to describe this is how many times have you had to call into a company to change a setting on your account? This puts your life on hold as well as the person's on the other end of the phone. With a good Salesforce implementation, your call center agents will never have to ask, who is this? What did you order? What is your address so I can enter it into my system, even though the customer already entered it when they purchased your product? If we can reduce these low-value tasks, agents can get through calls faster, waiting times will be reduced, and people can get their life back. And this is what I've dedicated my life to helping. So in case you're just walking in here randomly, my name is Jason Estevan, and I'm an integration engineer from Toronto in the Great White North. I've been programming since I was in high school, and I have no plans of stopping anytime soon. At Intuit, I'm part of the FACT division, which is the finance and compliance technology. And what we do is we orchestrate messages between our massive enterprise systems. and then package these processes into easy-to-consume APIs to enable other parts of the business. My life's vision is to reduce busy work by 1 billion hours. As you can see from the graph here on the right, I'm currently just short of 100,000, and most of this count has been with 2 big wins that I've had. One of them is a suite of payment integration apps for the Magento e-commerce platform, which allow merchants to manage their payments in one location, as well as stop the common practice of taking credit card information off a website and walking it to the front of their store to enter it manually in their point of sale system. The second big win is at Intuit. So we have an online tax offering for professional accountants that they can file tax returns for their customers. But in order to do it, they have to purchase what we call a bank. This is technically just a license or to make a filing. So the old way of doing it was that they would have to call into our call center to make the purchase that way. However, I created a couple of APIs so that now accountants can just do it with a few clicks from inside the product. And this was a big win for me. So this is currently up to 73,000 hours. And this is including the time that it takes, the Intuit waiting time, which I can't divulge what that is, and then the time it takes to actually fulfill the request, times by 2, because I'm not only wasting the accountant's time, but also the call center agents who could be helping a customer with a non-mundane task. So as you can see, I'm still pretty far away from my billion-hour target. The 2 biggest APIs at Intuit on our team are the API that allows someone to change their credit card information, as well as to cancel their subscription. So even though I've worked on these APIs, I technically didn't build them. They were built before I joined the team, so I can't really take credit for those hours. So I'm on to plan B, which is to help others reduce busy work in their organization. So now I'm going to take a step back and define what it is the field of integration engineering is. If you've ever purchased a desktop product of Intuit's 2 main product lines, QuickBooks or TurboTax, you would have seen on the last step of our e-commerce page a big Buy Now button. Clicking this button calls my team's Place Order API, and hopefully in less than 2 seconds, you would have seen an order success page. However, what you don't see is what's happening behind the scenes in that short period of time. If you're purchasing a physical product, we first check in our inventory systems to make sure that we have it on hand. Depending on when you're purchasing from, we have to calculate your taxes. We take your credit card information and we send it to our payment gateway to make sure that it's a valid credit card and that you have sufficient funds. We create a license for you in our licensing system so that you can access the product. If it's a subscription product, we enter you into the billing system so that you can be billed either annually or monthly. We create a username and password for you and our identity so you can get into the product. If it's a shippable product, we send it to the warehouse so they can send it to you. And lastly is to send an email to you with the order confirmation with some details on how to get into the product. And this is basically about half of the actual systems we talk to. And as you can probably guess, there's a lot of computer code needed to take the shopping button click event through this process. We need to push and pull data into different systems. Each systems have different structured models that we need to translate our data into. Different systems require access using different transfer methods, such as FTP, SOAP, REST, SQL. On top of all of this, we need to make all communications secure to protect data traveling across the internet, as well as handle any potential errors gracefully. This is what's called integration engineering. Here are the 3 most complicated tasks I have to deal with in being an integration engineer and how MuleSoft has made it multitudes easier. The first one is data transformations. If I'm transforming an XML file to an XML file before MuleSoft, I would have to create these 1,000-line XSLT spreadsheet files that has these complicated logic inside of it written in XML format. And this was just to handle XML. If I was dealing with JSON, I'd have to use a whole different method altogether. But MuleSoft provides what's called a transform message component, where it's a visual interface where I literally just with a few clicks, I drag and drop my mapping. So I choose my source file, my source field, to my destination field here on the right, and that creates my mapping for me. And it doesn't matter what type of data I'm transforming into or from, it still uses the same transform method. The second is transports. So what I have here is some basic code in Java, written in Java, on how to connect to a MySQL database. As you can see here, I load and install my drivers. I create my connection manager. I use a bunch of Java classes to create and execute my SQL, as well as I need to manage my connection pool. And even in case of error, I got to make sure that I have no memory leaks. Well, MuleSoft has these pre-built components that reduce all this code. So what I have here is an example of their pre-built database connector. So now, to connect to a database, all I need to do is create a configuration that I specify my username and password and URL to my database, and then just write my query, and everything else is taken care of for me. And the last one is connectors. So MuleSoft has simplified the logic needed to use some of the most popular APIs out there. So if you've ever connected to Salesforce using the SOAP or REST APIs, I feel your pain. I've gone through it myself. You have to manage your URLs. You have to make sure you have all your tag names correct, your values of the correct format. You got your SOAP headers accurate as well too. And this request here is just for it to log on. So once you make this request, you get a session ID, and then that session ID has to be included in every subsequent call to Salesforce afterwards. Well, MuleSoft has simplified that all with their Salesforce connector. So now all I have to do is specify my username, password, and security token, and all my session management and authentication is handled for me. I just make my calls to Salesforce, and behind the scenes, it handles all the logging in. So let's get back to our problem of reducing busy work by loading data into Salesforce. So there are two different types of data processing. One is batch, and the other is real-time. Batch is when data is collected over a period of time and processed by a separate program. It utilizes parallel processing of records to allow for high throughput. And because it's really heavy on the computer resources, it's usually run off hours or overnight. This fits in well with less time-sensitive data, such as extracting, transforming, and loading situations. And some of the downfalls are, as once a batch is started, you can't stop it for data integrity reasons, and it has very limited error handling. Real-time is when you have immediate processing on continual input. So this makes data available in the target systems immediately. It allows you to take actions on your errors, and it fits in well with time-sensitive data such as banking operations. So our update credit card API into it allows people to update the credit cards that we have on our file for them. And this is critical that it's a real-time system, because usually when someone is updating their credit card, it's because a purchase is coming shortly afterwards. So we have to make sure that the order coming shortly afterwards is using their new credit card information that they just entered. And it fits in well with analytics for immediate decision making. So this is tough to do, but if you can have your analytics reporting in real time, you can have up to the minute information on how your, say, marketing campaigns are running. So if you're running a daily marketing campaign, you can see throughout the day how it's going and potentially make tweaks to it. The downfall of real time is you're susceptible to load peaks, so you need to resource for highest utilization. So the busiest time at Intuit is by far the 3 days prior to the US tax peak. So we've purchased enough servers and set up enough configurations to handle thousands of transactions per minute. However, this is an extreme waste of money and resources for the remaining 362 days of the year. So let's get into our demos. Just get a drink here. So I'm inside Anypoint Studio, and this is our interface, IDE it's called, on where I design my Mule flows. So you'll see here on the right side, I have a Mule palette that has a list of all my connectors. So I literally drag and drop a connector onto my visual palette and then configure it to create my business process. So the way to read this, it's from left to right. So usually the first component is my event. So in this case, what I have is a timed scheduler. So it just shows that this is scheduled to start to trigger this batch job every 60 minutes. And then I triggered the rest of my components in my flow. So I take that event and I move from left to right with my record. So the business case we're going to do here to create this batch job is we're going to pretend we have an e-commerce website that takes orders and writes to a MySQL backend database. So I have my backend database here, and I have one record for every order that's placed on my website. So what I'm going to do here is that this is a database component that I was talking about earlier. This will pull all my orders from my database. In real life, it would probably be all new orders, but for this case, we're just going to pull every order in the database. And then we're going to pass it across this line here into our batch job. And then our batch job is going to process each record in parallel. That's how it gets the high throughput. And we're going to do is if you're familiar with the Salesforce order data model, it's actually 3 different objects that I need to write to. I need to first create my account object. I need to create my order object, and then I need to attach any items that was purchased using an order item. So writing to Salesforce, I have this Salesforce component. So this first one here, you can see it's the Salesforce icon with the green circle around it. I'm writing to my account. So this will create my account object in Salesforce. And as I was showing here before, to handle my login, all I have to do is in this config, put my username, password, and security token, and I never have to worry about logging in. And then I select from this pre-populated list what object I want to create in Salesforce. And MuleSoft does this really well. It'll actually pull this list from my account in Salesforce, including all my custom objects as well. So I just have to select from the list that I want an account. So that happens in this first batch step. The second batch step, I'm writing to my order type. And in the last step, I'm going to attach my products that were purchased and write to the order item object in Salesforce. So now I'm pulling from the database. I have writing to Salesforce. Now I just need to convert and transform the data models between the two. And this is done, what I described earlier is my transform message component. And this is the visual interface where I literally just drag and drop from the left to the right my field mapping. And on the right here, I have, MuleSoft has what's called data sense. So it'll detect that my transform message is beside my upload to Salesforce, and it'll see that I'm writing to an account object. So it'll pre-populate this right-hand bar with every field name and type of my object in Salesforce. So there's no need to log back into the product and get those crazy field names that are underscore C and all that jazz. So from the left here, I have all my database columns, and on the right, I have my object model. So it literally just dragging and dropping from the left to the right to create my mapping. And the code to create this is written here automatically on the right. So this is written in a language called DataWeave. It's MuleSoft's proprietary data transformation language, and its sole purpose is to transform data fast and efficiently and easily. So it does with key value pairs. So this is my field name in Salesforce, and this is my database key name. And you can see it's pretty much, in this case, a one-to-one mapping, except for I have a little bit of extra logic up here with shipping street. So we have a data mismatch that we need to handle. So in our database, our e-commerce database, you'll see that shipping street number and name are in 2 different columns. However, in the Salesforce account object, it's handled in one field called shipping street. So we do a simple concatenation, just adding a few plus signs, and it's handled. So that's the first step. The second step of the batch is to create the order, and again, we have a transform message, so we're taking 2 different column names from our database. Sorry, just one is just order date, and mapping it to effective date. And here we have a little bit of extra code in our DataWeave transformation. So we have a date formatting issue. So again, if I go back into our database, you'll see that my e-commerce site takes order date with a date and a time. However, in Salesforce, they only want the date in the effective date field. So what I do here is a simple date transformation with half a line of code. If I was to write this in Java, it'll be a few lines where I have to create a pattern and a matcher and a formatter, and I have to go to the ISO and get the date formatting codes. But in this case, it's just half a line of code, and my date formatting issue is handled for me. The last step, which I attached my order items to, Again, it's the same process. This time I'm taking my product ID and product and the amount fields from my database, mapping it to the order item, and creates this mapping here on the right. Here, I have a little bit of extra code. This is to handle my SKU differences. So this is a common scenario where in my e-commerce site, the SKU ID or product IDs don't match up to the crazy 18-character IDs that Salesforce provides. So what I'd have here is just a simple if-else to do that mapping because I'm only selling 2 products on my site. If you did have more products, you can easily put this into a database and query it. Not an issue. And the last step here is just I'm printing a log message that just says batch complete. So let me go ahead and run this to show you guys. I put a little breakpoint here, and I'm going to run it in debug mode so we can step through the code together. If you've been around integration engineering for a while, this might surprise you. I'm running a fully fledged ESB in an embedded instance inside Anypoint Studio. And it's actually quite powerful. I've done batch jobs with 100,000 records on it, and it has never crashed my computer. So my scheduler will trigger, it's every 60 minutes, but the first one starts as soon as my server starts up. So that should trigger right away, and then we should move on to our database component, and it should pause there because I put a little breakpoint. And there it is. You can see the box around it. So it's stopped, so I'm going to step through here. And now what I'm doing is I've read all my orders in my database, and you can see here I have 1 entry for every order in my database. And now I'm going to pass it to my batch job to process it in parallel. So I'm in my create account step, transforming the fields, and then uploading it to Salesforce. And as you can see, I went back to the first step. That is because that's the power of batch jobs. I'm processing all the records in parallel instead of taking one order all the way through from left to right and then going fetch the other one. So I'm doing this actually in 16 threads by default, but you configure it. So I can get really high throughput. So I should there's 4 orders in the database, so I should take it through that step. Now I'm creating my order in Salesforce 4 times. So if I was to stop the batch process right now, my data would be an inconsistent state. So in Salesforce, I would have orders that have accounts but no items to it. So that's why it's very important to not stop a batch job in process, because someone would have to go into Salesforce and manually fix that. So it should be 4 steps through, and then my log message. And then that's my batch job. So I should get a really nice log message that gives me a summary, and it's right here. So 4 records were processed, 4 of them were successful, and 0 failed. So that's great. So let me go into Salesforce just to make sure I ain't fooling anybody. See if our data made it there. Go into our orders. Always switching to all orders. If anybody knows how to make all orders a default, please let me know. It's such a pain. I can't stand that. And I have my orders here, which is great. It made it here. The account name is populated, so you know my account was created. And let's see if I attached my order products. And there it is. My products have been attached to my orders. So that's great. So that's our batch job. So now let me show you an example of a real-time flow. So this one, we have a little bit of a different use case. So for this one, we're going to pretend like we're an educational website that provides MuleSoft tutorials to people. So we offer, say we're offering our customers a free ebook. All they have to do is sign up on our website and we'll email their ebook for them. So we've created a form here with their first name, last name, email, and phone number. And when they hit download, we'll actually create we'll take their data that they submitted and create a lead in Salesforce. And this is kind of neat. So this web page is actually being served by MuleSoft itself. So when you're just web browsing, you're making HTTP GET requests. So for this request on /signup, inside our Mule flow down here, we have an HTTP listener, which is listening for /signup requests. And what we're doing here is we're going to return back an HTML page, which I have loaded in my project. So here's the HTML page that I'm returning back to the customer, and this is the form that got rendered. So once this form is submitted, let me show you the Mule flow that it triggers. It triggers this flow. So I have an HTTP listener on this one too, listening on pass/lead. And what I'm going to do here is I'm going to transform my data and create a record, a lead object in Salesforce. So again, I'm using the same configuration. This time I selected lead from my list. And now I just got to transform my form data into my lead object model. So again, drag and drop. So I have on the left side here, I have my field names that came from the form. And on the right here, I have the Salesforce field names that I want to map to. And it creates this mapping here on the right. So I have a little bit of extra code here that handles some mismatching. So in Salesforce, there's a company field name that's mandatory. However, a company doesn't make sense for my customers. So what I've done here is just hard-coded the word none that will get entered into every time I write up to Salesforce. And the second here is I created a function to do some data cleanup on the phone numbers coming in from the form. So if you give people a free text field to enter their phone number, you're going to get data in a whole bunch of different formats. They're going to have spaces, they're going to have hyphens, they're going to have brackets. So we just want to clean this up before we send it to Salesforce. So I've created a little function here called strip non-numbers, and I pass in the phone number that was passed in, and this calls this function that I created here that just strips off any number, any character that's not in the digit range from 0 to 9. So I just want to show you is that if you do have some complicated data transformations, it's still just a few lines of code to handle it. So after I upload to Salesforce, I have a little choice router here. So depending on whether Salesforce returns a success or false, I'm going to print a different log message. So if it's a success, I'm going to print successfully created lead in Salesforce to my logs. And if it's a failure, I'm going to print an error message that says failed while trying to create a lead in Salesforce. In actuality, I could probably do some extra error handling in this bottom section here, but for simplicity's sake, I'm just going to write a log message. And then this just specifies what message I'm going to return back to the customer. So in this case, I'm just returning back the message, thank you, please check your email for your download. So I'm going to put a breakpoint here, and we're going to submit our form. Pay no attention to that phone number. And I hit submit, and you'll see that I caught the event right away because it's a real-time process. I'm dealing with the form data as soon as it's submitted. So inside my payload or the message, I have my form data of type form URL encoded. But still, no problem, we can handle it with this transform message component. So transform message will translate it to my lead object. I'm going to upload it to Salesforce. Hopefully I go through the top route. Good. And then I write the message back to the customer, and let's check what the form is. The customer got the form. So this was the message I passed back. In actuality, what I could do is instead of just writing some text return back, I could send them to another web page, another HTML page, like an order confirmed HTML page. Or if I want to get real fancy, I can use the email send component, add it to here, and I could send them the email with the ebook already attached to it, all in my MuleFlow. So let me go into Salesforce and see if the lead was there. So this isn't a smoke show. And there's my lead that was created, 11:55, 11:56. So now this lead can be assigned to a sales representative who could follow up with the customer, ask them how they're liking their ebook, potentially offer them some of the other products that we're selling. Where's my database? So even though this code works, it's not exactly, I wouldn't release it into production. It's not exactly enterprise ready. So what I'll do to it is what we call hardening. So I just add some extra logic. Like for one example is retry logic. So whenever you're sending requests across the internet, there's a chance you might receive what's called a transient error. And this just means a temporary error. So if the Salesforce API is down for a few seconds, which just happened to be when you're making your request, or if some requests actually do get lost over the internet. So what I've created here is that if I wrap my Salesforce connector with this until successfully scope, I can program it so that if I get an error back, just wait a few seconds and then retry it again afterwards just to make sure that it wasn't a transient error. If it was a real legitimate error, what I could do is create a whole bunch of logic in my error handling. So MuleSoft allows me to use any component I can use in my flow inside my error handling. So I can create some pretty neat error handling. I can send an email to someone to let them know that there was an error with the system. I can use a different connector and create a ticket in Jira or Sales or in ServiceNow. Or I could get really fancy. If I kind of know why the errors happen and they're data related, I can just modify the data myself and resend it. And hopefully that'll solve the issue. And the last one is optimization for your batch jobs. So in our demo, for every order, there was 3 calls to Salesforce. If we were loading 100,000 records and orders into Salesforce, this would be a really long job. So what we could do is wrap our connector in what's called a batch aggregator. And what this will do is it'll batch or collect requests to Salesforce and then send them all at once to reduce all that back and forth and save a considerable amount of time in your batch job running process. If you're interested in learning more, I have a few URLs here I recommend that you check out. There's a whole bunch of great online tutorials and trainings. Also, there's a very vibrant MuleSoft meetup community that hosts regular meetups in major cities all around the world. And some last plugs is I have a YouTube channel where I upload technical MuleSoft tutorials that are just like this. A lot of screen sharing, a lot of walking through. If you're interested, please check it out. Just search my name on YouTube and you'll see my channel. As well as at Intuit, we're always searching for amazing people. So if you're interested for new opportunity or career change, please check out our website at careers.intuit.com. Sure thing. All right, so thanks for watching, and we'll see you next time. Peace.